Hello, viewers. In this tutorial, we'll be discussing exponential graphs. So we have just two basic type of exponential graph. Remember, we said f of x is equals to ax, and we have a condition on a. So a has to be greater than 0, and a is not equals to 1. And we said x is in the real number. So we're going to consider two categories of two categories for this graph. We're going to consider the situation where a is less than between 0 and 1, and also the category where a is greater than 1. So this we can illustrate with this simple example. If you look at this graph here, this is f of x is equals to 3x, 3 to power x. So in this case, our a is greater than 1, while in this case, our a is between what? 0 and what? And 1. So this is a here. Now we can use, this is a greater than 1. This is a between 0 and 1. So how do you graph? You can take points. Now, if you take the value, these are the point x, and these are, this is f, this is g. So if x is minus 3, remember the domain of exponential function is the whole R, because x can be any real number. So we can take positive and negative. If x is minus 3, put minus 3 here, you will have 1 over 27. But if you put it in this one, here is 1 over 3. If you put minus 1 over 3, substitute minus 1 over 3 as x, you'll have what? You'll have 27. Here, if you substitute x as minus 2, you substitute x here, you're going to have 3 to the power minus 2, which is minus 1 over 9. Why here it will be 9. Now, and you continue till the end. But if you try to plot this point, you will see that what? When you have 3 to the power x, you have an increasing graph, which is in red. But when you have, for this point, that is g of x, is going to be a decreasing graph. So this, in general, this is how the graph of exponential functions behave. So if a is greater, anytime you have your a to be greater than 1, is going to be an exponential function, an increasing function. And you can see this point is the intercept with the y-axis, because if x is equals to 0 and a is greater than 1, a to the power x, a to the power 0 is going to be 1. So that is why the y value here is 1. And also the same here, you also have 1, but this is decreasing. Now, one thing we can see about exponential function is that the domain is the whole of R. Because what is domain? Domain is coming from x, and the condition on x is that x can be any what? Real number. But if you look at the range in this case, the range is what? Is 0 open to where? To infinity. So this is the range, because this graph will keep coming close to 0. And it is the same when a is greater than 1 and when a is between 0 and 1. And another thing we can see here is exponential function of this form has a horizontal asymptote of y equals to 0. Because here you can see as s goes to minus infinity, your function goes to, as x goes to minus infinity, y goes to what? 0. So it means that y equals to 0 is a horizontal asymptote. Here we can see that at x goes to infinity, y is going to 0. So also we can conclude that y equals to 0 is a horizontal asymptote. Now this is just a quick one to show us what is the relationship. If you look at this, in this case, look at this part, this is how the numbers, for example, this is y to power 2x, but this is y to power 3x, and this is y to power what? 5x, and this is y to power what? 10x. So it's going to be all the same shape, but it's just that this one is the bigger the what? The bigger the base, the more closer it becomes to what stretch towards the y-axis. So it means that if you have y is equals to, for example, 15 to the power x, it's going to be somewhere here. It's going to pass somewhere here. So it's going to get closer and closer to the y-axis. This is in the case where all the a's are greater than 1. So as you can see, all these ones, all the a's are greater than 1. This is 10, this is 5, this is 3, and this is 2. But if you go to the other side, these, to the left-hand side, these are the cases where your a is all between 0 and 1. And what do we see? We see that you get stretched closer to the x-axis more when you have what? The smaller the number, right? Because you can see here, 1 over 2 is bigger than what? Than 1 over 10. So it comes closer to the y-axis when your what? The base is becomes smaller. So it's just like the opposite of the right-hand side. The right-hand side, the bigger the base, the closer you get stretched to the what? Towards the y-axis. But to the left-hand side, when a is between 0 and 1, the bigger the base, the farther away you are from the what? Stretch away from the y-axis. So basically here, we have some truth here. We've discussed the domain. We've discussed that the domain is a whole R. The range is 0 to 8. And the y-intercept is always 0 and 1. And it has no x-intercept. It is a one-to-one function because it satisfies the horizontal line test. And we have the y-asymptote to be 0 in both cases. So when a is greater than 1, we say the function is increasing. When a is between 0 and 1, we say the function is what? Is decreasing. So let's see example 6. So for example 6, we say find the exponential function f of x equals to a to power x, whose graph is given. So here you are given a graph. You just need to plot. You have the x value. You have the what? The y value. So we just need to find what is our a. So if this is equals to this, what is our y? Y is our f of x. So this is 25. And what is a? We're looking for a. X is what? Is 2. So it means that a squared is equals to 25. So a is going to be plus minus root of 25. And that means a is plus minus 5, right? But because of what? Because a has to be greater than 0, so we just take a to be equals to what? 5. So it means this equation, this graph represents 5 to power what? X. Similar here, we do the same story here. F of x is a to power x. So we just used 1 point is fine. So this is x, y is 1 over 8. So you have 1 over 8. And x is what? Is 3. So you can see that a is going to be the cube roots. So you take the cube root of 1 over 8. And that should be 1 over 2. So it means that the function, this function, it's simply 1 over 2 to power what? To power x. All right. Okay, so now this one example is talking about graphing functions using transformations, exponential function using transformations. So use the graph of 2 to power x to sketch the graph of the following. But we are to state the domain and also the range, the asymptotes, and also the intercept. So for this one, we can start with what? We can start with the graph of what? We can get this one actually from the graph of what? 2 to power x. So all we need to do is just a vertical translation of what? 1 unit upward, right? So this is all what is required. So 1 unit upward. So we can start with the graph of what? Of 2. This is 2 to power x, so it's going to be increasing. And this point is going to be 1, right? So this is the graph of 2 to power x. And so if you do one vertical translation, 1 unit, 1 unit up. So 1 unit up, what does that mean? It means the y value will change, right? So instead of cutting at 1, it's going to cut at where? At somewhere 2. So it will keep going. But something will change. You see here, when it's cut at 1, the horizontal asymptote is what? This is the horizontal asymptote. I call it HA. Is here is y is equals to what? 0. But now, since it's cutting at 2, your horizontal asymptote is going to be y equals to 1. So it means your graph will cut at 2, but it will come close to this one, right? So now, if we want to find the stories, we want to find the domain. So what will be the domain? The domain is still minus infinity to infinity. Then the range of this is going to be from where? It's going to be from that horizontal asymptote, which is going to be from 1 to infinity. Now, do we have asymptote? Yes, we have horizontal asymptotes. Now, exponential functions do not have vertical asymptote. So the horizontal asymptote is y is equals to 1. And what else? We have only y-intercept. So y-intercept is just the point 0, 2. So you can see that no x-intercept. So you can write x-intercept. There is none. Okay. And also we say there is no vertical asymptote. So vertical asymptote also none. Okay. So let's go to the next one. Now, this one is just what? This is just a reflection across the y-axis. So we can still start with what? With 2x. So this is 2 to power x. Now we reflect across the what? Sorry, this is reflection across the x-axis. So if we reflect across the x-axis, what would this be? So reflection across the x-axis, remember, which point is this? This is the original point 1. If you reflect across the x-axis, it means you're going to cut at -1. So it's just going to be something like this. So it will cut. So the cutting point, the intercept here is -1. But you see in this case, what happened? The horizontal asymptote will still remain the same. So this is it. We're done. So here, what will be the domain of this function? The domain is still the whole of R. Now, the range is going to be from where? From minus infinity to 0 open, because now you are below the x-axis. Now, you still have the horizontal asymptotes, which is y is equals to 0. And the vertical asymptotes, we don't have it. So we can talk about x-intercepts. Is there x-intercept? In this case, no x-intercept. So you can only talk about y-intercept, which in this case is 0 and what? -1. All right, so still dealing with this 2 to power x. So here is the same. You just need to what? You need to start with 2 to power x, and then you shift it. So 2 to power x. Then we shift what? How many units? Just this is now going to be horizontal translation, 1 unit, right? Because you have a minus here. So this is going to be, now this is what? This point is 1. So for 1, you just need to push it forward a little bit here, okay? Because if this is 1 and what? This is 0, 1. If you move it to the right, it's going to be what? It's going to be 1, 1. So this point now is 1, 1. So this is where it's going to like cut now. Okay, so it's going to be something like this, right? Okay, so now, but we need to know where is it going to cut? This is going up. So this side, we know it's going to cut, but how? Is it going to cut here or is it going to cut here? So this you can verify because it's this y-intercept. So you look at your function. Your function is what? Kx. So kx is what? Is 2x minus 1. So this is your y-intercept you are talking about now. Y-intercept means you put, it's like putting x to be 0. So you see this is 2 to power minus 1, which is going to be 1 over 2. So it's a positive number, but smaller than 1. So in that case, it means you have to draw it a little bit down here. And we continue. So this point is half here. And this point is half. And very close. So now, what do we say? We can talk about the domain. The domain is still minus infinity to infinity. That did not change. The range is still 0 to infinity. And now what is the horizontal asymptotes? Is still the line y equals to 0. And then you have the y-intercept. So in this case, what change is just the y-intercept? The y-intercept now is going to be 0 and what? And half. Now, does it have an x-intercept? Now, how do you check? We already from here, we know it doesn't have an x-intercept, but if you want to check what is x-intercept, let's say we want to find x-intercept, right? Remember, x-intercept means you put y is equals to 0, right? So let's see, it means that this is going to be 0. Okay, let's see. So you put k equals to 0 in that case. So you have 0 is equals to what? 2 to power what? X minus 1. Now, what does this mean? Is this possible for you to have 0 is equals to 2x to power what? Minus 1. Now, can we find x? Is there any x that satisfies that? So there's no x that satisfies this condition. So it means there is no x, because if you want to take, for example, you want to take the logarithm of 0, it's undefined. So, and there is no x-intercepts. Okay, so I think we can move to the next one. Now, if you look at this one, here we have something very new, which is the absolute value. So what do? We just start with what? We can rewrite this one. This is 1 over 3 to absolute value of x. Now we can use the definition of an absolute value. What is the definition of an absolute value? Remember, or let's say recall, that we have what? Absolute value of x is equals to x if your x is greater or equals to 0, or minus x if x is what? Less than 0. So if x is greater than 0, what do you have? You have 1 over 3. So if your x is greater than 0, it means absolute value of x will be x. So you can remove the absolute value and just put x. And here you can just put, you can say when x is greater equals to 0. But if x is less than 0, instead of absolute value, we use minus x. So it means you can have 1 over 3, but now minus x. And this is when x is less than 0. So if you look at what we did, we just used the definition of an absolute value to remove this absolute value. So you consider when x is positive, as well as when x is what? Is negative. If x is positive, you put x. If x is negative, you put minus x. Now we can rewrite these as what? We can rewrite these as 1 over 3 to power x when x is greater or equals to 0. But here you have minus here. So 1 over 3 to power minus x will just become what? 3x. And this is when x is less than what? Less than 0. So this is our function L of x. So this is L of x, right? So let's try to graph this now. To graph this, we just have two parts of the graph. The first part is when x is greater than 0. So when x is greater than 0, it means you are on this quadrant. You are in quadrant 1 and quadrant 4. In that case, you have 1 over 3. But as you can see, this 1 over 3 is what? Is decreasing, right? So we're dealing with 1 over 3, but we know that 1 over 3 is what? Is decreasing. So since it's decreasing, it means it's supposed to cut like this, right? Okay. So it's supposed to cut at where? At minus. So this is supposed to cut here like this, going close to 0. So this is actually 1 over 3. Why? Because 1 over 3 is between 0 and 1. But here, you cannot cross it to this side. It cannot continue going to this side. So you have to stop because it is at x greater equals to 0. So you have to remove any part that crossed to the other side. So it means it will just be something like this. So this part is what? Is 1 over 3 to power x when x is what? Greater equals to 0. Now, for the other parts, the second part is what? Is this one, which is an increasing function. So it is increasing, so it means it's going to be like this. It's supposed to keep going, right? But it cannot continue to go because you are only interested in the part that is less than 0. So it means you have to remove every part that cross the what? That cross 0. So it's just going to be this part. So this part is 3x when x is what? Less than 0. So this is just the two piece, but the whole thing together is what? Is the graph of 1 over 3 absolute value of x. So let's talk about this point. This point is still our 1, nothing changed. So the domain, what is the domain? The domain is still the whole of R, so still from minus infinity to infinity. Then the range, so you see the range in this case is what? Is 0 open, but where? 1 close, because this is the highest you can get. Then we have the horizontal asymptotes is still the line y is equals to 0. And you can talk about the y-intercept, which is 0.01. And then x-intercept, there is none. And also vertical asymptote is none. Oh, so let's move to the next question. Okay. So for the next question is this one, the E. This is a little bit, you have a lot to do here. To graph this one, you can start with the graph of what? The graph we just finished, because this one, you can start with the graph of three absolute value of x. So what does that mean? It means that you can start with this one. We already saw this graph. Okay, this one means what? Okay, I think we need to draw this one as well. Because the one we drew, the last example is 1 over 3. So let's start with 3 to power x. What is 3 to power x? Absolute value of x, just like we did before. This is just 3x when x is what? Greater or equals to 0. And 3 to power minus x if x is less than 0. And this we can write as what? 3 to power x if x is greater or equals to 0. And here, because of the minus here, it becomes 1 over 3 all to power x when x is less than 0. So what we can say now is what? We can try to plot this graph. So this is 3 to power x. 3 to power x is going to be increasing, so it's going to go like this. But this is when x is greater or equals to 0. So it means you need to keep only the part that is greater than 0. So this part, you have to remove it. So it's just this one here. So this is 3 to power x. Okay, then we have this one, 1 over 3 to power x, when x is less than 0. So it's 1 to power 1 over 3. 1 over 3 is between 0 and 1. So it's going to be a decreasing function, which is supposed to continue this way, right? Supposed to continue going like this. Yes, this is 1 over 3x. But because of the restriction, you are interested in the negative part. So it means we have to remove the positive part. So we will just stop here. So this will continue going. So this is 3 to power what? Or you can call it 1 over 3. 1 over 3 to power x, which is the same thing as 3 minus x. Okay, so the two together will give us what? Will give us, so this is the graph of 3 absolute value of x. Now, because of this plus 1, it means you need to move everything 1 unit to the left. So what we're going to do now is we will say horizontal translation 1 unit left. And what does that mean? It means we will have Remember, this is 0, 1. So you move it 1 unit to the left. It means it will come here. So we will start from here, which is going to be minus 1 and 1. Right. So this is 1. So it means it will just open up. Okay. So you see it's going to open up somewhere like this. So even though we don't know the intercept yet, don't worry. When we come to the final graph, we will know the intercept. So this is it. But we still need to what? We still need to go +2. It means we need to move everything 2 units what? Upward. So if you look at this one is going to be like our roughly our 3x plus what? Plus 1. Okay. Now, to get the final graph will be what? We need to move everything 2 units what? 2 units up. So the y values need to go 2 units up. So instead of, look at the y value here is 1. So instead of having it at 1, you have to move this point to where? To -1. You're moving it 2 units up, so it's going to go to the point 3. So let me do it here. It's just going to be something like this. So now the point is going to be here. This one will not change, -1, but this point is going to move 2 units up, which is 3. So your graph is just going to open up. Open up this way. Okay. But now what we need to take care, we need to know what will be our the vertical asymptotes. Because this graph will continue, the blue one will continue going, right? So this is how the graph will look like. Now, if you want to know the vertical asymptote, not the vertical asymptotes, the y-intercepts, so just use your definition of intercept, right? Because the function, what we're saying now is this function is 3 absolute value of x plus 1, everything plus what? Plus 2. So if you want to find the y-intercept, you want to know which point is this, just put x to be 0. If you put x to be 0, you will have 3 to power what? 3 to power 1, because 0 plus 1 is 1. So you have 3 power 1 plus 2, which is just what? Which is just 5. So it means that this point is what? Is the point 5. And then you're done. We can give every information we need. What is the domain? The domain will still be the whole R. Okay, but now we have to check the range, yes? What is the range now? What is the range? Our range is what? Our range is from 3, right? Yes. From 3 close to infinity. Now, does this have a horizontal asymptote? No, there is no horizontal asymptotes. But what about the y-intercept? Y-intercept when x is 0, we've seen it. If x is 0, y is going to be 5. Is there an x-intercept? No x-intercept. Everything is facing upward. There is only y-intercept. And there is no horizontal. There is no horizontal asymptote. Also, there is no vertical what? No vertical asymptotes. All right, so let's have one more. We have 2 more to go. Now for this one, we can rewrite this. We can write it as minus 1 over 4. Then we can take minus out so that you just have x plus 1 plus 2. So what can we do? We can start with the graph of what? 1 over 4, because our a here is 1 over 4, right? So we can start with the graph of 1 over 4. Then we reflect it across the what's the x-axis. So we can start by doing this, all of this together. Reflect across, is it y-axis? X-axis. The minus is outside, so let's start with x-axis. So what I'm saying is this. We have this graph. 1 over 4 is something like this. This is 1 over 4x, right? Now, because of this minus outside, so we can do what? Reflects across what? X-axis. If you reflect this across x-axis, what will it become? It will just become something like this. Across the x-axis, remember this is 1, so it means it's going to come to minus 1. So if you reflect across the x-axis, this is just going to be, let's say something like this, right? Yes. Now, this, it means that this one is minus 1 over 4x. But if you look here, you have another minus here. So we can reflect it across the what? The y-axis. Across the y-axis. And if you reflect it across the y-axis, what will change? It will just become this one. Let me do it on the same graph. The same point, but it will just become this one. So this one is minus 1 over 4, but with a minus x now, because we reflect across the what? The y-axis. Then all we need to do is we just need to move what? There is a plus here, so we just need to move 1 unit to the left. 1 unit to the left. So how do you move 1 unit to the left? 1 unit to the left simply means you move this point here, you move it to somewhere here. So I'll remove the blue one now. So you move it here, 1 unit to the left. So here becomes what? Minus 1. And once we do that, you will see that the graph will come somewhere here. This is the minus 1. Because you move this y-intercept will change. But the horizontal asymptote remains the same here. Okay? Then don't worry about this one. We can always find what is the y-intercept. So finally, we can what? We can add 2. 2 means you can take it up, right? So if you take it up, plus 2, this is plus 2, right? So if you go plus 2, it means you just move 2 unit up. So this one now here is minus half 1 over 2. So this is like plus 1. This is the whole of this. Then now you can just take everything 2 unit up. Remember this point, you know what is this point? So this is vertical translation 2 unit up. And now it will become something like this, 2 unit up. Remember this point, what is this point? This is the point minus 1 and 1. So if it is minus 1 and 1, you take it up to this point will become minus 1 and what? Minus 1 minus 1 and no, here it's minus 1, sorry, here. So this will be minus 1 and 1. And then it will just go up, something like this. And then our horizontal asymptote is going to be the line y is equals to 2. So let's see what is the y-intercept. We can always find the y-intercept. So for the y-intercept, what do you do as the y-intercept? The y-intercept is simply, you put x to be 0. Remember, we have our m of x equals to what? We can have minus 1 over 4 minus x plus 1 plus 2, right? So y-intercept is just m of 0, right? And this is going to be minus 1 over 4. If you put 0 here, you have minus 1 plus 2. And this will be minus, this is going to be 4 plus 2. This is actually going to be minus 2, you see? So it means that this graph is not cutting here, but it's going to cut negative axis. So you're going to cut at where? At minus 2 here. So this is our curve. It's cutting at the y-intercept is minus 2. And this will go here. All right, remember this point here is minus 1. This point here is minus 1 and 1. So we can say that the domain is still remains the same. And the range in this case is going to be from minus infinity to minus 2 open, because it's a horizontal asymptote. So it cannot touch. I hope we've seen that here. Okay. So you can see here, this is a horizontal asymptote. So it's not going to, did I say minus 2? 2. So this is, it's not going to touch it. But we have the y-intercept already. So our y-intercept, it's simply 0 and what? Minus 2. And also you see in this case, we also have x-intercept because the graph cuts. So what is our x-intercept? How do you find x-intercept? For x-intercept, what do? You put your y is equals to 0. And that simply means that what? You have 0 is equals to minus 1 over 4 minus x plus what? Plus 2. Now, if you take minus 2 here, this becomes minus 2 is equals to minus 1 over 4 minus x plus 1. This will be what's here. The minus will go with the minus. So you have 2 equals to. Now, if you look at this, you can rewrite this because this is the same thing as what? 2 to power. This is 1 over 4, right? 1 over 4, we know we can write it as 1 over 2 to power 2, right? So because of this minus, what can we say? We can take it up so that it just becomes what's, it just becomes 2 to power 2, right? Or let me write this as, because of this minus, I can just write this as 4 to power what's x plus 1. So now this is 2 is equals to this. We can write it as 2 to power 2 x plus 1. See? So we can drop the base. This is 2 to power 1. So this is 1 is equals to 2 into x plus 1. So 1 is going to be 2x plus a 2, right? So this will be 1 minus 2, which is minus 1 is equals to 2x. So x is what? Minus half. So it means that there is an x-intercept of what? Of minus half. So x-intercept in this case is minus half and what? And 0. All right. So this has a lot. So let me just a quick summary of this. What do? You reflect across the what? You rewrite this one. This is one way to do it. Then you reflect across the x-axis. This is first. Call it number 1. Number 2, you reflect across what? You reflect across y-axis. Then thirdly, you should what? You do vertical translation 1 unit left. And finally, you should do vertical. No, this is not vertical, but horizontal. Then finally, you do vertical translation 2 units up. So these 4 steps should give you this graph. And then you can know the intercept. Don't worry about the intercept. Just know the shape first. Then you can worry about the intercept by using our definition of y-intercept and what? And x-intercept. So for y-intercept, just put x to be 0. For x-intercept, put y to be 0 and try to solve. All right. So let's see this one more questions and we're done. So this one is this 4 to power x plus 1. So in absolute value. So quickly, here, what does this mean? This means is 4 to power x. It's simply this one is an increasing function. This is 4 to power x. Now, because of the 1, this 1 here, it means what? It means we go 1 unit right. So here we'll have horizontal translation 1 unit right. If you go 1 unit right, it will become what? It will become something like this. So it means instead of what? Instead of 0, 1, you will come to this point, which will be minus 1, 1. So it will cut like this. It will keep going, right? Now, we have everything here, but we have to move everything 2 units down because of this minus. Forget about the absolute value outside first. So this one, the absolute value is outside. So you need to finish what is inside before you implement the absolute value. So this now, what we can do is to move everything down. Look at this point. Which point is this? Remember, this point is minus 1, 1, right? So if I move it down, how many units? 2 units. If you move it down, y value down for 1 unit to be on 0. But if you move it here, it will be on where? On minus 1. Because you are moving 2 units down. So this point now is nothing but minus 1, minus 1. So it's going to cross this way, something like this. And now it will definitely cross the x-axis somewhere here. But if we are not sure of where it's going to cross, what do? We find the x-intercept. So this is, this one is going to be like this, right? So now this is this is moving 2 units down. Now, since it's moved 2 units down, we need to know what is this point. We don't know how is it going to cross. Is it going to cross the negative x-axis or the positive x-axis? So just find the x-intercept. So x-intercept, how do you find x-intercept? You put, x-intercept, yes. Or you can find both x and y-intercept. It's fine. So let's find with x-intercept. X-intercept, you put y is equals to what? Y is equals to 0. If you put y is equals to 0, you will have 0 is equals to absolute value of 4x plus 1 minus 2, right? So what does this mean? it means that you can remove the absolute value. So 0 is just 4x plus 1 minus 2. So it means that 2 is equals to 4x plus 1. You can write this as 2 to power 2 bracket x plus 1. So you have the same power now. So here should be power 1, right? So it means that 1 is equals to 2x plus, is it plus 2? Right? Yes, so we have minus 1 is equals to what? Is equals to 2x. So x is still minus 1 over 2, right? So it means that this graph is supposed to cut on the what? On the y. It's going to cut the x-axis at where? At minus, not at plus. So it's going to cut at minus half. All right. Now you can see it's also have a y-axis, a y-intercept. So what is the y-intercept? You can find the y-intercept. So the y-intercept, let me do that here. So let me do this here. So the y-intercept is you just take x to be what? 0. If x is equals to 0, you have absolute value of 0 minus 2. This is going to be 4 minus 2, which is just 2. So it means it's going to cut at where? At 2. So this is going to be at 0.2, right? Now we know, but now what do we need to do? We need to use the absolute value. Now, what does an absolute value mean? Remember, in this case, everything is inside the absolute value. So we know that the absolute value cannot be what? The absolute value cannot be negative. So this is what we have. Let me draw it here. This is it cutting at where? At minus half and also at 2. So we have something like this. Let me move a little bit to the so this is minus 1, 1. So we have something like this. So this is minus half and this is 2. But because this is an absolute value, it means you have to remove everything that is below the x-axis. So everything that is below the x-axis, look at from here to here is below the x-axis, right? So we have to reflect it across the x-axis. So it means from here, you just need to reflect it across the x-axis, which will be something like this. So this is just the reflection. Look at this part that's shaded here. You reflect it because it's below the x-axis, just reflect it across the x-axis, and it will be something like a curve here. To be something like a curve, right? So this will be this one, this way. So it means we have our curve. What is our final answer? Our final curve is this one, the one in black here. This one and this one. So this is the graph of absolute value of 4x plus 1 minus 2, or absolute value. All right, so I hope this video is helpful. If you have any question or you see anything, you can just put it in the comment section. Thank you for watching.